A QueChERS extraction is a simple and straightforward way to prepare food and agricultural products for multi-residue pesticide analysis. Available from Waters, the disc family of products was specifically created to simplify QueChERS extractions and reliably produce high-quality data. It consists of pre-weighed sorbents and buffers in both tubes and pouches, providing you with the flexibility to perform a variety of regulatory methods and protocols. There are a number of different variations to the QueChERS protocols in use worldwide, but all consist of the same basic series of steps. Step 1. Prepare your sample for extraction. Step 2. Transfer your sample to a 50 milliliter tube. Step 3. Add the extraction solvent and shake. Step 4. Add buffering salts and centrifuge. Step 5. Transfer the supernatant to a dispersive SPE cleanup tube and shake. Step 6. Centrifuge the cleanup tube. Step 7. Obtain your final extract and place it into an autosampler vial for analysis. Let's walk through these steps and discuss each one in detail. In order to obtain a more representative sample, it's advisable to use an entire fruit or vegetable when testing these types of raw commodities. In addition, the QueChERS procedure can be used to extract pesticides from prepared juices as well. Chop your sample into small pieces, removing the pit. Homogenize the sample. You'll only need about 15 grams, which is far less than other extraction procedures. Take an empty 50 millimeter centrifuge tube and add 15 grams of sample. You can adjust this amount for different analyte concentrations or sample types. Add 15 milliliters of your extraction solvent, acetonitrile in this case. Adding the acetonitrile to your sample prior to the buffering salts prevents clumping, which can interfere with your extraction. We now add the buffering salts to our sample and shake to mix. Be careful as this process may generate heat. In addition, the tube should be vented periodically to release any gas pressure. pH control is important during this step. The buffer salts are used to control pH and improve recoveries. The buffering helps to stabilize some of the more pH-sensitive analytes. Once the sample is thoroughly mixed, we are ready to centrifuge. Centrifuging separates the analytes from the solid material in our sample and removes interferences. The desired result is several distinct layers. The acetonitrile layer at the top should contain your analytes of interest. The next layer contains solid material from your sample. The third layer is the water layer, which contains polar interferences from your sample such as sugar. Without the water layer, the interferences would be present in the acetonitrile layer, which would make any further cleanup difficult. The bottom layer consists of undissolved buffer salts. We will remove the top acetonitrile layer for further cleanup because that is where our compounds of interest are. 1 milliliter of our extract is added to a dispersive SPE cleanup tube to further clean up the sample. In some instances, you may need more sensitivity. The disc family of products also includes 15 milliliter cleanup tubes, which can accommodate up to 6 milliliters of extract if necessary. After your sample is added to the 2 milliliter centrifuge cleanup tube, recap it and shake vigorously until the sample and sorbents are mixed. Now centrifuge the smaller cleanup tube in order to complete the sample cleanup process. The final extract from the 2 milliliter tube can now be removed and placed into an autosampler vial for either LC or GC analysis.